Welcome to EDU World Space.
What we know is that the EMF of the battery is 12 volts. The battery has an internal resistance of 0.4 ohms, and a resistor that's connected to this battery dissipates power at 80 watts. And we want to know what two values of R will dissipate power at 80 watts. So we know that power dissipated is the current times the voltage or the potential difference across the resistor. And we also know that the potential difference is equal to the EMF minus the drop across the internal resistance. So we can substitute the second part into the first part. So we have that the power is I times E minus IR. Okay, and we get that P is equal to IE minus I squared R. And I'm gonna rearrange this in a different way so that it'll be more suggestive. So if I have Ri squared minus EI plus P equals 0, this should remind you of a quadratic equation, right? So we have something like AX squared plus BX plus C, right? So we can write a quadratic AX squared plus BX plus C is equal to 0. And this has solution X is equal to minus B plus or minus square root of B squared minus 4AC, all of it over 2A. And we can identify A with R, right? Well, first we can identify X with I, right? And then A with R, and then B with minus I, and then C with P. So then if we do that, then we can just substitute into here. So we have we have I, right? So we get two values. Let's call them plus or minus. One correspond to the plus sign and one to the minus sign. Plus or minus is equal to over here. Sorry, there should be E. Okay, so we have E plus or minus square root of E squared minus 4 times R times P divided by 2R. So those are the two values of the current that we can find. And now if we plug in the numbers, so we have the EMF, we have internal resistance, we have power dissipated. So we can readily find I plus and I minus. So let's do that on the next page. So I plus will be 12 volts plus square root of 12 volts squared minus 4 times 0.4 ohms times 80 watts square root of that whole thing divided by 2 times 0.4 ohms. And that is equal to 20 amperes. And then I minus is equal to 12 volts minus square root of 12 volts squared minus 4 times 0.4 ohms times 80 watts divided by 2 times 0.4 ohms. And this is equal to 10 amperes. Okay, so now we're in a position to find the resistance. So we'll use this equation. So the power dissipated is equal to I squared times R. And here we can isolate R, and we can say that R is equal to P over I squared. And remember that we have two values of I, so we have one that corresponds to I plus and one that corresponds to I minus, which are 20 amperes and 10 amperes respectively. So we can have two R's, so R plus, which will be P over I plus squared, which is equal to 80 watts, right? Because we want to know what R is when the power is 80 watts divided by I plus, which is 20 amperes. So this gives us a value of 0.2 ohms. And now R minus, which will be P over I minus squared, which is also 80 watts, over 10 amperes. Sorry, that is squared. 10 amperes squared. And this is equal to 0.8 ohms. So those are the two values of the resistance, 0.2 and 0.8 ohms, that will satisfy a power of 80 watts that's being dissipated.